Hello students, I hope you are all fine, taking care of your health as well as your family members. Lockdown has lasted very long and we are not fully sure that when the condition will become normal. In wake of that, we are devising various methods to reach you. As a part of that effort, this is a video lecture which I am trying to develop it. This has been only my second video lecture. I am learning the art of it and obviously there will be some limitations. Do bear with it. Also, I must warn you that I'm recording this and I have in my house two young kids which are totally out of control. They can come at any time. So, if they come, you have to bear it and concentrate. Now, coming back to teaching part, why I have decided to give a video lecture on cluster computing because I've already announced in our WhatsApp group that this will be a topic of test, this along with mosaics. I thought I should explain to you the relationship between mosaics and cluster computing and how these two are related and why they are combined in one single test. So let me first explain you what will be in the this video. This video will contain following 6 topics. It will be what is cluster, how the cluster is better than multiprocessor, what are the various cluster configurations. I will touch upon the cluster architect, issues involved in cluster operating system, and then before going we'll briefly touch upon what is mosaics and how it is related to the cluster computing. So this is 6 things which we'll be discussing. So I'll start by picking up what is cluster. So cluster is an interconnected computer which are giving to its user the illusion of a single computer, and these interconnected computers are working with some unified cause. So the formal definition is sort of there on the screen, but if you want a better understanding, probably the example of Google, Amazon, Facebook, YouTube, or any big websites will work because these websites are working with the cluster at the back end. It is just not possible for any of these websites to provide you the services and not have a cluster for the sports. In fact, they are the most pioneer example of cluster computing because without cluster computing, there is no way that Google can ensure that everybody in this world at all places at all time are able to use without failing the Google web services. That, if you think, is a phenomenal service which is only made possible because of the presence of the cluster architect. If you look at the books and the literature, then you'll see how the cluster will look like. It will come out with a figure like this, which tells that this is a multiple computer and computing devices interconnected among each other. In fact, this is one of the configuration and we'll reach how this configuration is reached. So we'll park that thought here, that what is the meaning of this figure. But mind you, this is one of the configuration of the cluster computing. There are many configurations. So I'll continue with a brief question that why do we need cluster? We need cluster because we want powerful, strong and fast computer. We will always want that. We want that 20 years back. We will want that 20 years from now. We'll always want that 50 years from now because that's just in the nature of humans. So what is happening is with the single processor systems, we are already reaching at the upper layer of the computations. So we need to devise another method to make the computer faster and powerful. So cluster is one of the examples. But then the natural question is, why do we connect so many systems? Why, for example, we never have something like multiple processors being introduced in a computer, so that is what we call it as multiprocessor systems. In fact, that is a topic which we will also discuss in section 1, which is symmetric multiprocessor, which is also a way to make the computers powerful and stronger. Hereby, we don't have a large number of computers, but we have what we call it as a multiple processor in a single computer. This has its own advantages. For example, it is easier to manage and configure as compared to cluster. It looks like a normal computer. Its operating systems are easier to design, and it consumes less power and less space, which is obviously very easy as compared to cluster operating system or cluster computers, because the cluster computer uh, can span over continents. Actually, they may not last at one place. For example, Google is providing web services to almost all, but Google has a cluster which span across the globe actually. Now coming back to the advantages of cluster vis-a-vis any other configuration, and more specifically SMP, and they are simply the three factors which are scalability, availability, and reduced cost, that is high performance to cost ratio. By scalability, I means that the power of the systems can be scaled up by any amount, by any number of PCs, and there is no upward limit. And that is a unique thing about a cluster configuration, because in cluster configuration we can scale up the system as and when desired. So the Google, the Facebooks, and the WhatsApp of the world are not worried if the number of subscriber becomes double, triple, or whatever it, because they will simply add the cluster sufficiently so as to provide the service to everybody. Availability is another point. By availability means the system is always available. The last time the Google was off was 2.5 years back, and at that time it was probably in Europe and parts of Southeast Asia, where the Google was not working for 30-35 minutes, and that was a big news actually. So think of the amount of availability that they ensure. This is purely because the cluster is just always available. And perhaps the most important points in favor of the cluster as compared to any other configuration is that the cluster has a reduced cost, in a sense that uh, if you add the number of the PCs, the overall addition in the computation power and the amount of the cost which has to be added, that's the most favorable advantages. Configurations, there are many configurations. The first one is a passive standby configuration, which is also referred to as a simple standby server configuration. It is just like a server providing the service to the clients, and there is another second passive system which is just waiting. When the first system goes down, it takes over the work, thereby availability and the service is not down. Although in most of the cases the second server could be of a lesser capacity than the first server and would not be able to provide that powerful performance as the first one, but at least the system is afloat and it is not broken. The second configuration is, which is an active secondary configuration, and this basically is a configuration like this. Here there is a common memory space, and both the servers are working on both the spaces depending upon their power. So what was the disadvantage of the first system? That it was cost inefficient, in a sense that the first system will always be free, and it will for most of the time it will be free, and in this second system both the systems are working, so it overcomes the limitation of the first system. But however, there is one complexity, that it increases the complexity of the systems. Two systems working on the same memory requires some discipline actually. The third configuration is a separate server. So as the organizations become larger, so they develop a sort of a separate server. For example, there is this organization which will have a separate server for their login and password, a separate server for their database, a separate server for their file handling, and separate server for their say a backup of the memories. So That type of system is basically involves a large number of systems, and it ensures high availability. But one limitation of this system is that there is too much network traffic, and service overhead is also there. So the third system is various system connected to the uh, disks, and it looks something like this, which was our starting figure of the cluster configurations. So the advantages are there that all memory space is largely at one location. In fact, there could be many, but once the disk fails or once the server fails, so that requires more complicated systems to handle this type of configurations. The last configuration which we'll discuss is server with shared disks, and it is something which we called as data centers. Ultimately, most of the systems are working into this configuration, and here what is happening is that all data, all softwares are at one places, which is what we normally call it as data center. It reduces the network traffic, and the failure due to disk crashing is also reduced. But uh, again, because multiple server, multiple memory locations, and there is no bar, so that requires certain locking facilities on data as well as files, and that is a sophisticated things which need to be held. And this is one work of a cluster operating systems. Next, I had a topic which is operating system issues. Once we want to design a cluster operating system, so this will also have an operating systems. Remember, we are doing advanced operating systems, and these are advancement vis-a-vis various types of operating systems. So a cluster operating systems should handle a failure management, load balancing, parallelization issues, single system image. It should provide checkpoints. That means it should take the backup at periodic processes, and then due to the server failure or disk failure, the process migrations should be handled at the operating system level. So that is the issues which has to be designed. And so the last slide in this is cluster architect. Most of the books have a diagram which is something like this. And if you look carefully at this diagram, this lower portion is basically internet or a network. This middle portion is a hardware portion of things, which is in a various configuration, which we have just discussed. This upper portion is the issues which are to be handled at the operating system point of view. So one of the operating system which is a part of our syllabus is MOSIX. MOSIX is a cluster operating systems, and which tries to handle the upper portion of the things. My next video will be on the topic of the MOSIX. A special thanks for Dr. Prateek Bhatia of Thapar Universities, who was a big motivation in encouraging me to go for the video. And thanks for watching.